Why am I wrapped in a blanket standing next to a greenhouse on one of the hottest days of the year? Well, you've probably heard of the greenhouse effect. It's fundamental to understanding what keeps our planet warm and why our climate changes over time. The problem is the greenhouse metaphor isn't a very good one. The greenhouse, like the rest of the planet, receives incoming radiation from the sun, which passes easily through the glass, just as it does through the atmosphere. Some of that incoming sunlight is absorbed by the surfaces inside the greenhouse, and like all objects, the plants and the soil in the greenhouse re-emit heat radiation at long wavelengths that are invisible to us. So far, so good with the analogy. The heat radiation coming off objects inside the greenhouse tries to escape to space, and some of that heat is trapped on the way out by the glass, but only a little bit. The problem is that what really warms a greenhouse up is the prevention of airflow, stopping the loss of heat by convection. Whereas what helps keep the Earth warm is the presence of certain gases in the atmosphere that absorb heat radiation and re-emit some of it back down to the surface. These are known as greenhouse gases, and the result is called the greenhouse effect. But really, these gases function more like a blanket around the planet. A blanket traps heat and re-radiates some of it back to whoever is lucky or unlucky enough to be rolled up in it. Let's get out of the greenhouse and see how incoming sunlight is balanced by outgoing heat radiation from the Earth. As we've already established, visible shortwave radiation comes through the Earth's atmosphere. Some is reflected by clouds, a bit is scattered by particles in the atmosphere, a little bit is absorbed by ozone and other gases, but the remainder reaches the Earth's surface. There it can either be absorbed or reflected back through the atmosphere towards space. The fraction that is reflected depends on the nature of the Earth's surface and is called the albedo. Some surfaces, like ice and snow, reflect a lot of radiation. They have a high albedo. Other surfaces, like the ocean, absorb a lot of radiation. They have a low albedo. So removing sea ice cover and exposing the dark ocean underneath causes the Earth to absorb a lot more radiation. Overall, the Earth reflects about 30% of the sunlight that reaches it from space. In other words, it has an albedo of around 0.3. But if it was just down to the absorption of 70% of the sunlight that reaches the Earth, we would all be freezing, as our planet would have an average temperature of 18 degrees centigrade below zero. Instead, we have the blanket of gases in the Earth's atmosphere to thank for warming the surface by 33 degrees to a balmy average temperature of 15 degrees centigrade. Let's recap how that works. First, the Earth emits radiation as heat. Then some of that heat radiation is at the right wavelength to be absorbed by gases in the atmosphere. These gases in turn give off heat radiation, and some of it comes back to the Earth's surface. So what are those key gases? Carbon dioxide is what most of us would identify as the most important gas in this blanket, but actually it's water vapour that plays the most important role in keeping our planet warm. Other important gases are methane, ozone and nitrous oxide.